Hey there, welcome back to the deep dive. You're looking for a deep dive into systems analysis and design, specifically this textbook by Alan Dennis, Barbara Haley Wixom, and Roberto Roth.
Absolutely. It's a classic in the field.
So are we ready to unpack this dense but fascinating world of building software systems?
You bet. It's like we're going to build a software system together from the ground up using this book as our guide.
I like that analogy. So where do we even begin?
Well, the book really stresses the importance of planning.
Right, like laying the foundation before you build a house.
Exactly. You can't just start coding without a solid plan.
Okay, so what does planning look like in the world of software development?
The book calls it the system request. It's basically a blueprint that outlines the need for the system and the value it brings.
Like a pitch, you need that clear vision up front, right?
Exactly. And it also needs to be feasible. That's where feasibility studies come in technical, economic, and organizational.
So it's like checking if you have the right tools, the budget, and the team before you even start.
Right. You've got to make sure it's actually doable.
Makes sense.
And the book gets into some pretty specific techniques for assessing economic feasibility, like cash flow analysis and ROI.
It's not just about building cool tech, it's about building smart and within budget.
Exactly.
So once we've got a solid plan and we know what's feasible, what's next?
Then we move into the analysis phase.
Okay, and what happens during analysis?
This phase is all about gathering requirements, figuring out what the system needs to do.
So how do we go about gathering those requirements? Is it just a matter of asking people what they want?
Well, it's more than that. The book recommends techniques like interviews, JD sessions, and even observing how users currently work.
JD sessions sound interesting. What are those?
They're like brainstorming sessions on steroids. You bring together the project team, users, and even management to hash out the system requirements.
So it's a collaborative effort.
Absolutely. And the book highlights how JD can help reduce scope creep, which is when a project keeps expanding beyond its original goals.
Scope creep. That sounds like a nightmare, especially if you have a limited budget and timeline.
It can be. That's why clear communication and a well-defined scope are so important from the get-go.
Okay, so we've gathered our requirements and we've avoided scope creep. Now what? Do we start designing the system?
Yes, but before we jump into the actual design, there's one more step in the analysis phase, defining use cases.
Use cases. What are those exactly?
Think of them like walking through different scenarios step by step, imagining you're a user trying to accomplish a specific task.
So it's like a story about how someone would use the system.
Yeah. The use case maps out how a user would interact with the system to achieve a specific goal. It helps us make sure the system actually meets the user's needs.
That makes sense. So we got our requirements, we've avoided scope creep, and we've defined our use cases. Now we're finally ready to design the system.
Almost. The book mentions something called data flow diagrams.
Okay, so we've got our use cases mapped out. The book also mentions these things called data flow diagrams. These sound pretty technical.
They can be, but think of them as maps that show how information moves through the system.
So we're talking about data now, not just user actions.
Right. The data flow diagram shows us how data enters the system, what processes it goes through, and where it ends up.
Interesting.
It helps us see the big picture of how data flows through the system, which is crucial for designing a system that's efficient and effective.
So after all that analysis, we finally get to the design phase, right? This is where we figure out the HRW, the nuts and bolts of the system.
Yeah, this is where it starts to get real. We choose an architecture like client-server or cloud-based and select the right hardware and software.
Okay, so lots of technical decisions to make here.
Absolutely. And the book really emphasizes the importance of non-functional requirements here, like security and scalability.
Security is huge these days.
It is. You also have to think about things like performance, maintainability, and usability.
Right. It's not just about making the system work. It's about making it work well and in a way that users will actually enjoy.
Exactly. User interface design plays a big role here.
And speaking of user experience, the book talks a lot about user interface design. It's not just about making things look pretty, is it?
Definitely not. It's about user experience, or UX. A well-designed interface is intuitive, easy to navigate, and maybe even a little bit fun to use.
So it's about making the system not just functional, but also enjoyable to use.
Exactly. Think about a website you love to use. It's probably easy to navigate, visually appealing, and doesn't make you want to pull your hair out.
That's good UX design.
Right. And it all starts with understanding your users and their needs.
Okay, so we've designed our system, but the software world is constantly changing. How do we keep up with all the new technologies and trends?
That's where agile methodologies come in.
The book spends quite a bit of time on agile.
Agile is all about being flexible and adapting to change. It's like being a nimble gymnast, ready to adjust your routine on the fly.
That's a great analogy. So how does agile work in practice?
The Agile Manifesto lays out the key principles. It prioritizes individuals and interactions, responding to change, and working software over rigid processes and documentation.
So it's more about people and results than sticking to a rigid plan.
Exactly. Agile recognizes that things change, and we need to be able to adapt. It's about embracing change rather than fearing it.
And within the world of agile, Scrum seems to be the rock star, right? What's so special about Scrum?
Scrum is a framework for implementing Agile. It's all about short development cycles called sprints, where we focus on delivering working software quickly and iteratively.
So instead of trying to build the entire system at once, we break it down into smaller chunks and deliver them incrementally.
Exactly. And we get constant feedback from users along the way, which helps us ensure we're building the right thing.
So we've designed the system, embraced agile methodologies, and now it's time to actually build the software, right? Is that where we're headed next?
We are. But before we dive into the nitty-gritty of coding, there's a whole world of testing to explore.
Right, we can't just release software without making sure it actually works.
Exactly. Testing is crucial for ensuring quality and catching bugs before they become major problems.
So what's on the agenda for part 2 of our deep dive?
We'll be tackling the world of data modeling, where we'll learn how to design the structure that holds all the information in our system. Think databases, tables, and relationships.
Sounds fascinating. I can't wait to learn more. See you in part 2.
See you then.
Welcome back to the deep dive. We're ready to tackle data modeling, right?
We are. Data modeling is all about designing the structure that holds all the information in our system.
Okay, so it's like creating a blueprint, but for data instead of a building.
Exactly. Just like an architect needs blueprints to build a house, we need data models to build a system.
So where do we even begin with data modeling?
The book starts with logical data models. Think of these as high-level sketches before we get into the nitty-gritty details.
Okay, so logical data models are like the concept drawings.
Exactly. They help us understand the big picture of what data we need and how it's all connected.
Got it. And what tools do we use to create these logical data models? The book mentions entity relationship diagrams.
ERDs, yeah. They're the bread and butter of data modeling.
I've heard of ERDs, but I'm a little fuzzy on the details.
No problem. Think of them like family trees for your data, showing how everything is related.
Okay, so how do ERDs work?
You've got boxes representing entities, which are basically the things your system cares about, like customers, orders, products.
Okay, so each box is a category of data.
Right. And then you have lines connecting those boxes, showing the relationships between them.
So if you had a line between customer and order, it would mean a customer can place an order.
Exactly. And those relationships have special properties like cardinality and modality, which the book explains in detail.
Cardinality and modality, those sound a bit intimidating.
They're not so bad once you get the hang of them. Cardinality is all about numbers. One customer can have many orders, but each order belongs to only one customer.
Okay, so cardinality is about how many of each entity can be related to each other.
Right, and modality is about whether a relationship is optional or mandatory. Like, can an order exist without a customer? Probably not.
So modality is about the rules of the relationship.
Exactly. And these rules are super important for ensuring data integrity.
Data integrity, what does that mean?
It means making sure the data is accurate and consistent. For example, we don't want an order floating around in our system that doesn't belong to a customer.
That makes sense. So ERDs aren't just pretty pictures. They help us define the rules and relationships that govern our data.
Right, and as we gather more information during the analysis phase, we can refine our ERDs and make them more detailed.
Got it. The book also mentions metadata, which sounds kind of meta.
Metadata is data about data. Think of it like labels on your data that explain what it all means.
Okay, give me an example.
Like, what does customer name actually mean? What format should it be in? Are there any special rules for it, like a maximum length? Metadata helps everyone understand the data and how to use it correctly.
So it's like a data dictionary.
Exactly. It provides context and meaning to our data.
Makes sense. So we've got our logical data model all figured out with our ERDs and metadata. What's next?
The next step is normalization.
Normalization. Sounds like we're putting our data through a car wash.
It's kind of like that. Normalization is all about organizing the data to avoid redundancy and inconsistencies.
Redundancy. like repeating the same information in multiple places.
Exactly. Normalization helps us eliminate that redundancy and make our database more efficient.
So it's like cleaning up our data and making it more organized.
Right. It also helps us prevent errors and ensure data integrity.
I'm starting to see how important this all is.
It really is the foundation of a well-designed system.
So we've normalized our logical data model. What happens then?
Once our logical data model is nice and tidy, we translate it into a physical data model.
Okay, so we're moving from the conceptual to the concrete.
Exactly. This is where we get specific about how the data will actually be stored, like what kind of database we'll use, what tables and columns we'll have.
So if our entities are like the characters in a play, the physical data model is the stage they'll perform on.
Love that analogy. And just like a stage needs specific props and lighting, the physical data model specifies all those technical details, data types, keys, indexes. It's the blueprint for our database builders.
Okay, but then the book throws us a curveball, denormalization. Isn't that the opposite of what we just did?
It is. But sometimes, for performance reasons, we need to bend the rules a little. Denormalization is like strategically adding some redundancy back into the database.
Why would we do that after we just worked so hard to eliminate redundancy?
It's a trade-off between data purity and speed. Think of it like this. If you always need to access the same piece of information, it might be faster to have a copy of it readily available, even if it means a little bit of duplication.
So it's like creating a shortcut.
Exactly. And that's the art of data modeling, making those smart decisions based on the specific requirements of your system.
Okay, so data modeling is all about finding the right balance between good database design and real-world performance needs.
Right. And once we've got our data model nailed down, we can move on to program design, which is where we'll actually start building the software that will bring our system to life.
I'm ready for the next challenge.
Great, because in the next part of our deep dive, we'll explore how to design the programs that will make our system work, from those high-level modules down to the nitty-gritty details of the code.
I can't wait. See you in part 3. Welcome back to the deep dive. We've made it to the final part of our journey through systems analysis and design.
We've covered a lot of ground, from planning and analysis to data modeling and program design. Now it's time to talk about bringing our system to life testing, implementation, and navigating the always interesting world of change management.
Sounds like the home stretch, but probably still a lot to cover.
Absolutely. We've built this incredible system on paper, but now we need to make sure it actually works in the real world. And that's where testing comes in.
Right, we can't just release software without making sure it's, well, ready for prime time.
Exactly. And testing isn't just a one-time thing. It's an ongoing process throughout the entire development lifecycle.
So we're constantly testing and refining as we go.
Right. But in this phase, it's all about systematic testing to ensure the system meets all the requirements and performs as expected. And the book breaks down testing into different levels, each with its own focus.
Okay, so let's unpack those levels. What's the first one?
First up is unit testing. This is where we test each individual component in isolation.
So it's like making sure each part works on its own before we try to assemble the whole thing.
Exactly. We want to make sure each unit is functioning correctly before we move on to bigger tests.
Makes sense. What comes after unit testing?
Next is integration testing. This is where we see how those individual units work together.
So we're checking if the pieces fit together and communicate properly.
Right. We want to make sure data is flowing smoothly between the different components and that they're working together harmoniously.
Got it. Then there's system testing, right, where we look at the whole system.
Exactly. System testing is like taking the entire system for a test drive. We're making sure it meets all the requirements, that it performs well under load, and that it's secure and reliable.
So it's the big comprehensive test.
It is. We're testing the entire system as a whole, from end to end.
And finally, we have acceptance testing.
This is where we bring in the users and let them try out the system. We want to make sure it meets their needs and expectations, that it's easy to use, and that it solves their problems.
So it's the real world test.
Exactly. We're getting feedback from the people who will actually be using the system day in and day out.
Makes sense. And there are different types of acceptance testing, right?
Yes. There's alpha testing, which is typically done in-house with a select group of users, and beta testing, where we release the system to a wider audience for feedback.
So by the time we get to the implementation phase, we're pretty confident that we've got a solid, well-tested system.
That's the goal. Of course, testing doesn't end there. We'll continue to monitor the system after it's live, but this rigorous testing process helps us minimize risks and set us up for a successful launch.
Speaking of implementation, What does that actually look like? Is it just a matter of flipping a switch?
Not quite. There are different strategies for implementing a new system, and the book breaks them down along three dimensions: conversion style, conversion location, and conversion modules.
Okay, so let's start with conversion styles. What are some of the options?
One option is direct conversion, sometimes called Big Bang conversion. It's like ripping off a Band-Aid. We switch from the old system to the new system all at once.
So we're going cold turkey.
Exactly. It's the quickest approach, but it also carries the most risk.
Right. If something goes wrong, we don't have a fallback.
Exactly. Another option is parallel conversion, where we run the old system and the new system side by side for a while.
So it's like having a safety net.
Right. We can compare the outputs of both systems, make sure everything is working as expected, and gradually transition users to the new system.
Less risky, but probably more work.
It is more work, but it can be a good option for mission-critical systems where we need to be extra cautious.
And what about phased conversion?
Phase conversion is where we roll out the new system in stages, one piece at a time.
So we're slowly introducing the new system to the organization.
Exactly. This can be a good option for large, complex systems where a big bang approach would be too disruptive.
So it's all about finding the right implementation strategy for the specific situation?
Absolutely. There's no one-size-fits-all solution. The best approach depends on the complexity of the system, the level of risk tolerance, and the organization's overall change management strategy.
And speaking of change management, the book stresses the importance of addressing the human side of implementation. We can't just focus on the technology, right?
Absolutely. We need to bring people along on the journey, communicate the benefits of the new system, and address any concerns they might have.
So it's about managing the people as much as the technology.
Exactly. And that starts with understanding that change can be difficult for people. Even positive change can be met with resistance.
So how do we overcome that resistance?
By being proactive. We need to identify potential resistance early on and have a plan to address it.
Okay, so what does that look like in practice?
It starts with communication. We need to communicate clearly and consistently about the new system, its benefits, and how it will impact people's work.
So keep people informed and involved throughout the process.
Exactly. And we also need to provide training and support to help people learn the new system and feel comfortable using it.
Makes sense. It's all about making the transition as smooth as possible.
Right. And celebrating successes along the way. It's important to acknowledge the hard work and effort that goes into implementing a new system and to celebrate the positive outcomes.
Wow, we've covered a lot of ground in this deep dive. From the initial planning stages to the final implementation, it's been quite a journey.
It has. And this book has been an invaluable guide packed with practical advice and insights for anyone involved in building software systems.
And it's not just about software, is it? These principles apply to any complex project.
Absolutely. Whether you're building a system, launching a new product, or even just reorganizing your closet, these principles can help you achieve success.
So, for our listeners out there, remember that the keys to success are planning, analysis, design, testing, implementation, and a good dose of change management.
And never underestimate the importance of communication, collaboration, and a willingness to embrace change.
That's a great note to end on. Thanks for joining us on this deep dive into the world of systems analysis and design.
It's been a pleasure.
Until next time, keep learning, keep building, and keep those systems running smoothly.